All right, well, welcome back. What we're going to do today is we're going to go through some derivatives, and we're going to specifically look at what is the product rule and quotient rule. All right, well, what we got here is I have a couple of functions, all right, that we're going to take the derivatives of. Here we have a function where we have x to the fourth times the quantity 1 minus 2 over x plus 1. Now, when you're finding derivatives, we may use the product rule or quotient rule. And just to kind of really recap in our first tutorial. All right, product rule of a function is when you have a function and you're multiplying f times h. All right, so a function times another function. To find the derivative, I always say we take the derivative of the first times the second plus the derivative of the second function times the first, and then you simplify and you can get your answer. All right, so that's the product rule. We have another one, which we know is known as the quotient rule. The quotient rule is used when you have a function divided by another function. So if I want to find h prime using the quotient rule, I would start the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Okay, so we're going to have bottom squared. All right, so in this, we're going to use the product and quotient rule when we take different derivatives. So we're going to look at our first example. An example, I'm going to call it example number 3, okay? Because I actually did 2 other examples in class. But what we have right here is we're going to find the derivative of f. Now, to find the derivative of f, one thing we want to do first is we could use the product rule, but I would always suggest simplify, all right? Use your algebra skills to pay the bills first in order to solve this. So what we're going to do is I'm going to take x to the fourth. I'm going to distribute that through to each one of these terms, okay? So I'm going to have x to the fourth minus 2x to the fourth over x plus 1. All right. Now what we did was we just eliminated using several different rules repeatedly when we find our derivative. All right. So now from here, we are now going to, I think we're ready to take the derivative. So I'm going to take the derivative of this. So I'm going to label this f prime. We're going to use the power rule here. So we're going to take the derivative of x to the fourth, which is 4x to the third. And now here, I'm going to take, and I'm going to use the quotient rule. All right. So I'm going to use the quotient rule. Say minus the derivative of the top, which will be 8x to the third, times the bottom, which is x plus 1, all right, minus the derivative of the bottom, which is 1, times the top, which is 2x to the fourth, all over the bottom squared. So we're going to go x plus 1 and x quantity squared, and that is what we got. All right. Now, from here, this is our derivative. That's the derivative of that function, okay, when we simplified it, and that would be our answer. But I'm going to go one little bit step farther. We're going to simplify this a little bit. Okay, I'm going to take this right here. So 4x to the third, we can probably leave that alone. But I'm going to take this, I'm going to simplify this expression a little bit. I'm going to take 8x to the fourth plus 8x cubed, all right, minus 2x to the fourth. So we're going to clean that up a little bit. We have x plus 1 squared. Excuse me. All right, so now we have is f prime again. So we have 4x cubed. We're going to have a minus, all right, and we'll put this right here. Combine these, so we have 6x to the fourth plus 8x to the third. And then we're going to have the quantity x plus 1 squared. We could probably combine this a little bit more if we wanted to, but I'm going to say right now, I'm going to stop, and that's going to be our answer. All right, so using the product, or actually multiplied, so we can use the quotient rule. So that was our first example. Well, let's try one more before I cut off, and we'll do some more a little bit later. But here we go. Here's an example of where we have 3 different functions being multiplied. Now, when you have this, one thing we could do is we could actually simplify this entire thing and just use the power rule. We could also go through and we could simplify and use the product rule here. So I'm going to actually use the product rule just for practice. Now, before we use the product rule states we only is a product when we have 2 functions, f times g. Well, we have 1, 2, 3 functions, so we have to get rid of one of them. To do that, we're going to distribute and simplify. I'm going to take 1 and 2 because they're binomials, and I'm just going to multiply them. So we're going to have, I'm going to change this up to x to the fourth. Now I'm going to have plus x squared. I'll have minus x to the third, and then we'll have minus x right there. I'll keep x squared plus x plus 1 right there. And we'll simplify this a little bit. See if we can. Actually, we can't. All right, good. So this is what our f is. Okay, and now from here, I'm going to find its derivative, and I'm going to use the product rule. So now this is going to be f and also g. So the product rule states I'm going to take the derivative of the first function. So I'm going to take the derivative of this. So I get 4x to the third plus 2x, use the product rule, minus 3x squared minus 1. All right, so that's the derivative of my first function. I'm going to multiply that by my second. I'm going to add that to the derivative of now my second function, which is right there. So I have 2x plus 1 times my first one, which is x to the fourth plus x squared minus x cubed. Oops, yep, x cubed minus x, and there we have it. All right. And if we want to, we could clean this up, distribute through, and I guess I'll do that. All right. This actually would be our derivative. All right, that long monstrosity of a function, all right, of that derivative. But we're going to clean this up a little bit. I'm going to distribute this through. So I have 4x to the fifth plus 2x cubed minus 3x to the fourth. Hopefully I'm doing all my algebra right. Plus we're going to have 4x to the fourth plus 2x squared minus 3x to the third. All right, minus 1. Oops, minus x. I apologize. Minus x. And then finally, this one we're going to have, holy moly, all right, plus 4x cubed plus 2x minus 3x squared minus 1. All right, and that's just this side. Holy moly. All right, we didn't even get to the second part. See if I can simplify this a little bit before I go on to this next one. All right, so I'm going to have 4x fifth. We got any cubes here? Here's a cube, here's a cube, here's a cube. So we have 2x cubed, we got negative 1x cubed, and then we have that, so we plus 3x cubed. Let's go with my fours, and that's it. So we're gonna have plus 1x to the fourth. All right, we got x squared's here, x squared there, so we got just 1x squared, positive, and we got there. So that's going to be 1 positive, and we have minus 2x squared there. Any x's from Texas, we got this will be plus 1x. I'm going to add those all together with that. And then minus 1 appears. That's what we got for that part. We're going to then take this, and I'll multiply this through. All right. And I'll just put this down right down the bottom here. So I didn't do this part. I'll underline this thing. So I didn't do that part yet. I'm going to put that right here. All right, and do my final thing so I have room. All right, so what we have is 2x to the fifth. That's going to turn into plus 2x to the third minus 2x to the fourth minus 2x squared. And we'll go plus x to the fourth plus x squared minus x to the third minus x. And there we have it. All right. And then let's just simplify all this cool stuff. I'll add green here for my final answer. I got 6x to the fifths. Holy cow, this is huge. We have right here, it's going to be 5x thirds. We're going to have negative x to the fourths. We're going to have minus. No, wait, man. What do I got here? This and this. Actually, these will cancel out. I'm sorry. X to the fourth appears to be canceling out here. This one and that one. All right, and then we got one right here just sitting there. All right, so that's going to cancel out. Cool. All right, my x squareds. Okay, so that's going to be negative 4x squared plus an x squared. So it's going to be negative 3x squared. My x's, I got 1x here. I got 1x there. Will that cancel out? That cancels out that. And just make sure my thirds, third, 5, and I got another third there. Oops, it's going to turn to 4. 4x to the thirds. All right, so that'll be plus 4x to the thirds. All right, or 6. Oops, golly. See, this is why I don't like simplifying. A lot of fun, right? All right, so we have fives. So that and that we just did. Any more fives? Oh, and we got the threes. Okay, thirds, 3 thirds, five right there, and we have one right there. So 5 be 4. Yep, I guess I was right. 4x to the thirds, x to the fourth, negative x to the fourth, positive fourth. So that's going to be canceled out. We got our negative x squared. We got negative 4x squared plus an x squared, meaning a 3x squared. Beautiful. And then I think the only thing that's left over is the -1. And so there is our simplified answer. Woo! That was painful. But going through here, um, this is the product rule. This is actually the derivative of this long um, function right there, the product of three functions, which combined to two, which we then simplified from here after we did our derivative using the product rule. All right, we're going to stop here. Hope this helps you out. We're going to do some more. We're going to do two more product and quotient rule in our next tutorial. All right, good luck and God bless.